Hello friends, I'm back with another video. This time I was working with some dynamic routing and redistribution of route and wanted to make a quick video for those studying CCNA and maybe CCNP. Now I wanted to talk about how to enable EIGRP, which is fairly simple, how to enable RIP, and then how to enable OSPF. So in this instance, we have here the network from here to here is an EIGRP network that will be working to establish adjacency between the two. Then from here all the way down here, we'll work with RIP, and then this last piece right here will work with getting the adjacency for OSPF. Then once that's done, what I want to do is I want to make sure that routes from EIGRP are being sent into RIP, and then routes from RIP are also being sent back in the other direction for RIP. And then on this side over here, we want the same thing. We want the RIP routes to be able to be redistributed into OSPF, and then get OSPF to redistribute its routes into RIP, so that in the end EIGRP can see all the way down here into the OSPF. At the end, I want to make sure that PC2 is able to reach PC1 with a simple ping, with unicast ping, and I want to enable multicast in all of these interfaces. I want to get multicast going so that we can join multicast at these ends, and we can have also multicast traffic being shared between PC2 and PC1. Stick with me. Hopefully you're able to make it through the video. I will try to make it as quick as possible. As always, you can pause the video if you need to. All right, so to get you familiar real quick with this architecture, right here where we have PC1 already marked, we have R1 with 3 loopbacks. That would be 111, 10, 10, 10, 100, 100, and of course the network down here going on G03, which we see it right here. Then for R2, there are no computers or other devices hooking up from it, so we just have the 3 loopbacks on the 2s, so we can associate it with number 2. And of course, we have some of these loopbacks are being advertised or will be advertised into OSPF, and then some others will be advertised into RIP. We have the network, the shared network for RIP between 2 and 3, and we have 2 more loopbacks on router 3 and 2 more loopbacks on router 4, along with the network that's being shared between the 2, also running on RIP. And then from these loopbacks, I think 1 and 1 will be distributed, 1 for EIGRP and 1 for RIP. I think that's how I want to play it out. And of course, the network for RIP, which will be a shared network between R4 and R5. And R5 would also be advertising these networks into EIGRP along with the network here for R5. So if we go to R5 and look at the quick configuration there, that will be the 51 network, that not just 50, which is a loopback, but 51 that's also coming from G03. All right, so without any further ado, I'm going to start here from the left side, configuring OSPF. I'll try to make the video as short as possible for you, so it's not as boring. As a matter of fact, so there are a few ways that we can share the or add networks to OSPF. In this case, I want to do it this way. So 0 all the way to loopback to area 0. And just like that, all my loopbacks are participating on OSPF. INT branch, and the way we'll do that is G03, and I will say IP OSPF1 area 0. And just like that, my interfaces, the hard interfaces and the loopback interfaces are both participating in OSPF. We'll move on to router 2 and do the same thing, 0 to 1, area 0. And just like that, we should see the neighbors coming up with all the information coming from OSPF. Perfect. Now let's do the right side, the G00. Yeah, that will be on RIP. So we'll do router RIP, and then we'll say the network. Let's do the 1 loopback that we have, network 10.0.0.0, just like that. And we already did the no auto summary. And one thing I missed here is version 2 that allow us to do the classless. All right, let's go into a router 3 interface 00. So we'll do router RIP 00, no auto summary version 2, and just like that, we should have already some adjacencies from RIP and some information for RIP coming up. But before I do that, I want to add this loopback 0. So INT, that information for that is net. I also want to do 30. So network 30, 30, 30, 30, just like that. So we have 0, 0, and it's the same network for 10, 0, 1, 0. Let's see, what do we have here? Do show run section RIP. All right, so that network 10, 0, 0, 0 should be part of that, but if not, we do network 10, 0, 1, 0, and let's see if it takes that. Cool. All right, so it's already included in there. All right, let's do a quick do show IP route, and then we do RIP, and we have some RIP information from the left side. We have that loopback 200 participating already. Perfect. And if you notice, we don't have 2222 or 2020 because those two loopbacks belong in OSPF. This is to show us in this case that OSPF and RIP are not communicating, right? So in this case, we have OSPF running all of these networks, including these two right here, and we have RIP running this 200 and also running these loopbacks along with this and this, right? So the two are not sharing each other, and that's part of what this exercise is going to be. But before I do that, I'm going to continue to do the other RIPs over here and EIGRP here as well. All right, so we'll move on. So we'll do that by doing router RIP. Let's start with 444 or network 444, and we do auto summary version 2. The next network we have is network 10, 0, 0, 1, 0. And it's going to be the same as we had before, but for some reason I just like to do it in the event that they don't match. As a matter of fact, I got to take that one out because that one is going to belong to EIGRP and not RIP. Okay, so we have the 4 and the 10 already added for RIP, EIGRP, and whatever your autonomous number is going to be. For me, it's going to be just one for today. Network, I want to add that 40. Okay, and do no auto summary here as well. And then include the network for 10, 0, 3, 0. And in this case, we add this wildcard. Good. All right, so router 4 and router 5, we have the routing tables here. On router 5, we can see the only thing that's being advertised there as EIGRP is this puppy right here. 40 is the only thing that's being learned from this router 4 through EIGRP. It's the only routing protocol running on this router. Now on the other router, on router 4, we have all of these that are being learned through EIGRP, all those D's right there. So D for EIGRP, R for RIP, connected, and local. So that's on router 4. Looking at router 1, when we look at that routing table, so we are now introduced to the O for OSPF. What is being learned here on OSPF, it's the number 2 network that's being learned from G00 as OSPF. We have some more locals and some connected networks. Notice there is no R's here, no R's, there is no D's. That is R1. Let's look at R2. What do we have in R2? So now on R2, we have a mix again of R's for RIP. So whatever is being learned on RIP, some connected, some local, more RIPs, connected, local, RIPs, and OSPF being learned from router 1, some more RIP for router 3, and that 100, which is coming also from the router running OSPF on the left side, which is right here, OSPF 101 also running from OSPF. So now notice, as I mentioned before, that there is no sharing of routes between the actual dynamic protocols. So between RIP, OSPF, and EIGRP, there is no sharing of that. That has to be manually configured. So what that causes is that if you're trying to ping from R1 to any of these other routers that are running a different protocol than OSPF, you're simply not going to be able to connect unless we work on that redistribution. So we'll start redistributing from this side, from OSPF. So we do, and then we do RIP. That redistribution will take place in this case in router 2. Why router 2? Because out of router 2, we will have RIP this way, OSPF this way. So it pretty much bridges the two. So if we go to R3, there is no point on doing redistribution there. We go to R4, and then again, we are able to do redistribution because we have EIGRP on this side and we have RIP on this side. And we want to be able to share the two just like this. So that's from OSPF into RIP, and then we'll back it up, go to router RIP, redistribute OSPF 1, and then we add a metric. I will add a metric of 2 with OSPF. If we go up here, E1 would be external type 1, E2 is external type 2. That external type 2, it's that that RIP going into OSPF. In R3, we can see the metric here. Metric of 2, that's the metric that we share going from OSPF into RIP. So now we'll go into R2 and do the business there. So we'll go router RIP, redistribute EIGRP, and that was EIGRP metric I5. There we go. And then going from router EIGRP, redistribute RIP, and then we do metric 1000, 100, 255, 150. So we have done both ways. Now we should be able to see router 5 with a bunch of information on it now. Okay, show IP route. So we have EIGRP externals. So let's look at what EX stands for. EX, EIGRP external, right? What is being learned through EIGRP. And then that's a daisy chain of what's being also learned from RIP and learned from OSPF. Let's see what we have here. Show IP route. Perfect. All these E2s that are being learned through RIP, whether it's learned in RIP or it's learned in EIGRP. Great, so that's going from here all the way to here, back the other way once, and that's pinging all the way back. Perfect. All right, so that's from PC1 or PC2 to PC1 and PC1 to PC2. So that's pinging. Let's do a quick trace route and see how that looks like in the multicast group. What we have done is added following interfaces, this interface and this interface to IP PIM, and then small. We will have to do the same thing for this interface, this interface, this interface, this interface, this, and this. Then at the last router or last hop, we would do this join command that you see on the screen. So this command will also have to be done with EIGRP join, and then that's the 23911, right? And that's what's going to enable us going into multicast, and then multicast will find its route all the way back to those that are participating in the multicast group. Let's do router 2 now. And that's it for that. We got the neighbors coming up. We would do this. We'll go 3, add that in there. 4, run the 2 commands. Not on the PC, we do on the router. All right, so just like that, we're able to check right dead center. Show IP, PIM, neighbors, right? Who my neighbors are, to the left and to the right. And also do show IP, M route. We are able to see that we have not joined any groups just yet. It's just the default group join. 239. Well, so that interface is now requesting to participate. We'll do this one more time. And notice there is no route selected for multicast. As soon as we go here and say 100 times, want to do the same thing on PC2, 10 times, we're getting some replies. So if we go back to the middle, show M route, we can see now that we have some traffic going on for the start coma and the source for the multicast, and what is the actual route to get there, which is 51002. In this case, that would be this area right here. All right, so we can now see PC1 and PC2 getting some multicast traffic at both ends and being routed through the entire network successfully. And just like that, we have completed this long lab redistribution of dynamic routing and also participating in multicast traffic for PIM dense mode. Thank you for watching. I hope you enjoyed the video and learned something from it.